I think one of the things that we need to really understand about circular motion is that if something is moving in a circle, then something must be causing. There must be a force being applied to this object. We know from Newton's first law that objects tend to continue to move in uniform motion or stay stationary unless there is an external force acting upon it. So this object right here would much rather just continue in a straight line, but apparently it's moving in a circle. And so we know that there must be a force acting upon it. Okay, that could be, for example, gravity, like a planet orbiting a star, or a moon orbiting a planet, or satellite orbiting a planet. But there is some sort of force nonetheless acting upon that. And then that force is always going to be perpendicular at right angles to the motion at the time. Okay, that's if it's a circular motion. If it's an ellipse, that's not necessarily going to be the case. But for circular motion, that is going to be the case. Okay, so far so good. So I think one of the things that we want to think about is that one of the things we need to realize about this is that this object is accelerating. Now that's kind of a weird concept, because if it's moving at a constant speed, how can it be accelerating? So let's start off with that question. If we imagine that if it's taking, let's say, 5 seconds to go around this circle, and it's always 5 seconds, and then so the frequency is, well, the time period is 5 seconds. Frequency would be 1/5, but so it's going to stay that. So the speed, imagine the distance of the entire circle, and then divide that by 5. The speed would always be the same. But how can we say therefore it's accelerating if the speed's remaining constant? So one of the things that we want to realize about the concept of acceleration is not the rate of change of speed, but is the rate of change of velocity. Now, we know velocity and speed are very similar, but not the same. So what's the difference between velocity and speed? Exactly right. Good. So you know your definitions well. So yeah, velocity has size and direction, or magnitude and direction, and speed just has direction. So if this object was moving over here, let's say at 10 meters per second, or whatever it might be, maybe it's 10 meters per second, and then over here, a little while later, it's also moving at 10 meters per second. I'm just going to actually just copy that circle there. The speed remains the same, but the velocity has not remained the same. In fact, maybe for my purposes, it's going to be a little bit easier just to do that one there. So, or just past the arrow, yeah. So, and then if we do that there, let's try to do that again. It's a bit tricky to get it exactly right. Actually, I'm going to take some arrow shapes and attach them so it's a bit easier. So if we've got as this shape moves around there, in order for it to keep going, the force that it's feeling is moving towards the center, and the velocity is now over there. If in terms of the speed, nothing's changed because the size of the velocity is still 10 meters per second. Okay, but let's actually look at how we would actually calculate the change. In fact, we know that. Hang on a second. We know that acceleration is equal to the change in velocity, so the final velocity minus the initial velocity divided by time. I'm going to call this one here u, and that one v. All right, and then we're going to actually calculate the change in velocity, which you'd think would just be 10 take away 10 over t, but it's not going to be that, and I'll show you why in a moment. I'm just going to chop this up into a second video though.